Hello everyone. I hope you can hear me. Is my audio audible? Thank you. Okay. So I'm Pavitra. Welcome to Calculus 2. So before I get started with Lab 1, I would like to give you some information on the Blackboard. Okay, and then we can continue with the Lab 1. Fine. So only Lab 1 is going to be online, and from next week, it is going to be both face-to-face and also online. Okay. So you can use the same meeting link, and if it is asking you for the passcode, I have already uploaded the passcode in the Blackboard and also in the Teams. Okay. So you can make use of that. And if you wish to come in person to the classes, you need not bring your personal laptop or computer because the labs already have Matlab installed in the computers. So you can make use of that. And okay, let's get started with the Blackboard. Let me share the screen. Fine. Now, so everything, any materials or resources you need related to your lab, everything will be available only in this section. Okay. Do not go to your lecture section if you need any information regarding lab. So any information regarding lab will be only available in your lab section. Okay. Now, just click on the course content. I mean, if you want to log into Blackboard right now, you can do. Okay. And then click on the course content. So as soon as you do that, you will see the syllabus copy, and then you have a Zoom meeting link here. So if you just click on the Zoom meeting link here, it will take you to Zoom. Okay, you don't have to log in or just copy and paste the Zoom meeting link. You don't have to do anything. So you just have to click on the link. If it is asking for you to sign in, you can sign in, and then you will be logged into the Zoom. Okay. And next, what you have is the lab manual. Let me click on the link here. So I have uploaded a link in the Blackboard. So if you click on that link, it will take you to Calculus 2 labs. Okay. And if you're not able to log into the Blackboard right now, only for as of now, you can just type Matlab Falcon on your Google Chrome or Safari. Okay, on your web browser, just type as Matlab Falcon and click on the first link. Okay, it will take you to all the calculus labs. Fine. Since yours is calculus 2, click on labs in calculus 2. And you will have all your labs. Okay, you can do that. And coming back to the Blackboard here. Now, once you have access to the lab manual, you will be completing your lab assignments, and you will be uploading your lab assignment here. So this is not the link, but it is a folder. You have to click on the folder and you will have assignment 1 link visible. Okay. So the due date will be starting from today till 1 week. I have also mentioned the due date here, and it is going to be the midnight. Okay, on February 3rd, midnight. Okay, just click on the link and you can just click on browse local files. That will take to the document wherever you have saved. You can upload that document. Okay. And in addition to this, I have allowed 3 multiple attempts. Okay. So if you have not uploaded the right document in the first attempt, you can always go back and then upload the correct document in the second time. But remember, you cannot delete the first document. Okay, so I will be seeing both the documents, the correct one and the incorrect one. So I might not be knowing which document is correct, right? So for that, you can, let me show this. So here you have right submission, right? So here you can just type it as I have uploaded the right document in second attempt, if it is second attempt. Okay, so if you just write like this, I will know that I should be grading only the second document. Okay, so that will really help. Okay, coming back to the course content here. Now there is no video links uploaded here because right now I'm teaching. So once I'm done teaching, I will be uploading the LAB1 video here. Okay, so that is all about your Blackboard. You will have Zoom meeting link, lab manual link, lab assignment, lab videos, everything under course content. Okay, you do not have to search anywhere else. Fine. Okay, and about attendance, attendance is not mandatory. I will not be taking any attendance, and there is no extra grade or points for the attendance. Fine. And the assignments are going to be individual assignments. If I come across any similar assignments, then I would have to give you a 0 points and inform to your respective lecture instructor. So please do not let me do that. Make sure you write your own assignment. Do not copy from the previous semester because there are few changes which are done in this new semester. So make sure you write your own assignment. Okay. Having said that, if you have any questions till now, please feel free to unmute yourself or you can just drop your questions in the chat box. Okay. Okay. So meanwhile, I want you all to click on the lab manual, or you can just go to Matlab Falcon in the web browser. Okay. And then I want you all to open lab manual 1. Simultaneously, just open your Matlab software. I hope you have installed it because you would have completed your calculus 1, right? So if you do not have Matlab software right now, you can log into Matlab Online. Just type Matlab Online. You must have the MathWork account and then only you will be allowed to use this online Matlab, right? If you just click on start using Matlab Online, you can just use the Matlab without the software, right? Okay, now let's get started with lab 1. If you have any questions in between the teaching, please feel free to drop your questions in the chat box or you can unmute yourself, okay? Fine. Okay, so lab 1, today, I hope you would have completed your chapter 1 by now, in your lecture section. So lab 1 is all about Riemann sums and estimation of the area. Okay, so you will be learning on how to evaluate Riemann sum, how to find the area, how to solve definite integrals, using MATLAB software. Got it? So that's what we are going to do today. Now, before I get into the MATLAB or the coding, let me give you let me give you a quick introduction about Riemann Sum. Now, let's assume that we have a curve, okay? We have some function, and this is the curve of that function. Now, I want to find the area below this curve, okay? The area below this curve from 0.1 to 0.5, just a random number, okay? How can I do this? If I have a rectangle or if I have a square, I know the formula, area formula, and I can easily find that, right? What if I have something like a curve or an irregular shape? Then what does Riemann sum do is that it will divide the area, the irregular shape, into rectangle, okay? Then let's say that I have a one big rectangle. I will divide that into one big rectangle. What is the problem now? The problem here is we have extra area here, which will be added to the original area. And that will not give us the accurate answer or the approximate answer, right? So what do? We divide this rectangle into some number of points. So let's say I will divide this into 1, 2, 3, and so on. Okay, I keep dividing, and I don't want this big rectangle, not this one. So I divide in such a way that I want rectangles to fit inside this curve. I do not want any rectangles to be outside. I want the entire rectangle to be placed inside the curve. Fine. So how many number of rectangles do I need? That is defined as n. So n is here. In this lab, it will be called as number of sub-intervals. Number of sub-intervals. Okay. And the space between each rectangle, that is given by delta x. This will be your f of x. This is delta x. Now, how can I find the area? Remember, this is going to be a rectangle, right? What is the area of a rectangle? It is length into width or breadth, right? So here, area according to Riemann will be width is delta x, and the height here is given by f of x, right? Delta x into f of x, correct? And this is an area of only one rectangle. Now, if I want the area of all the rectangles present here, what do? I will just introduce summation function. That means I am going to add all the f of x present here. Now, I have summation only for f of x and not for delta x. Do you know why? That's because delta x is going to be same for all the rectangles. Okay, when you divide the curve into equal sub-intervals, the delta x is going to be same. Delta x will vary only if you vary n. Okay, keep that in mind. And that's the reason we have upper sum defined as delta x summation of f of x. Okay, that's how we get the formula. Okay, that's enough of the theory. Now let us get straight into problem 1. Now, how do we compute this using Matlab? Right? So this is the function given. They want us to find what is the upper sum and the lower sum. And interval is also given. Okay. Now, just a recap of calculus 1. Now, let's say that I will give you f of x to be 3x, and I want you to find what is f at x equal to 1. What do you do? How do you do this in MATLAB? You just assign a value for this variable x equal to 1, and then you say f equal to 3 multiplied with x, right? And then if you just run this, you will get answer f as 3 on the other screen, command window. That's what you are doing. Now, what if I give you x equal to 1, 1, 2, 3, 4? What if I give you 4 values? Can you do this? Can you do the same thing? You can try right now if you want. Now, if you do this, the MATLAB will throw some error saying you must give only one input. Okay, here you have 4 inputs. MATLAB wants only one input. It can evaluate using only one input. Now, what can I do? You have to use dot operation. Okay, you have to use dot operation when your input is a vector. Fine. When you do this, you will get f value. So we are going to use dot operation because we have an interval which is nothing but input of vectors. Okay, that input is nothing but the vector. So since we have a vector input, we are going to use a dot operation. Okay, so that makes sense. Now, why are we using this inline function? That's because, remember, they want us to find both upper Riemann sum and lower Riemann sum. That means we will have two intervals, that is upper interval and lower interval, right? Two things. Agree? Now, we are supposed to find f at these two intervals. We have f as same, only one function, but we have two intervals here. Now, what am I supposed to do? You can do like this, but then you will have to change the variable name. Okay, if you write it as x equal to 1, 2, 3, 4. Okay, let's say upper limit as 1, 2, 3, 4, and lower limit as -1, -2, -3, -4. And if you say f equal to 3 dot x u, then what about Excel? How do you do this? Okay, if you say that I will just take it as f equal to 3 dot xl, then you have same names, right? You have to change this variable, you have to change this, you have to change this. So I can do that, but just imagine if you have a very large vectors or a very large function, that just requires more storage space, right? So we are supposed to eliminate all those extra or unnecessary things. So what can we do? One idea is that we can define it as f of x, right? And just say f equal to 3x and then end it. So whenever you want, you can just call this function, use it for any kind of interval. You can do that, or you can still reduce this 3 line of code into 1 line and write it as inline function. Okay, inline function. Very simple, right? So, and that's the reason why we are using inline function in this LAB1. Remember, we are using inline function because we are supposed to call this function for different interval. Okay, and we are using dot operation because our input is a vector. Understood? Okay, let's move on. Now, I told you that upper sum has a formula delta x dot summation f of x, right? Now I need to find delta x. So you have formula of delta x as b minus a divided by n. That's what they have done here. Fine. Now this is how you will find xu. Now we are using linspace because that's the Matlab command built-in function. So if you want the values from 1, 2 with 10 divisions, we use linspace. So linspace is a Matlab built-in command which will give us a vector from start point to end point and with equal subintervals. Okay. Now, in the same way, we define the lower interval, and then we are going to define upper Riemann sum formula. Okay, this is easy. Okay, this as well. Now, when you have this problem, you are going to find delta x, you are going to find xu, xl, and then using this xu and xl, you will find upper sum, lower sum, and then finally we want to estimate the area, right? So I can just call it as estimate or area. Let me call it as estimate of the area, and you have formula as us plus ls divided by 2, and then you have to find the error between us and ls divided by 2. This is the formula. So we have to do all these things using MATLAB software. Okay, fine. Now that was all about problem 1. Now for problem 2, you have a different function, but you have some values of n. So you are supposed to find out the upper Riemann sum, lower Riemann sum, estimate, error, even the delta x for each value of n. Okay, that is going to be your assignment number, assignment 1, problem number 2. Okay, now once you complete this, they want you to make a table with values of n, delta, and error. And then you are supposed to answer this question as well. Okay, you need to answer what will happen if n increases, what happens to error, and if error is decreasing, what is happening to delta. So you need to write what kind of relation is there between n, error, delta, and maximum error. Okay, this is going to be a theory question. You can just answer it in like 3 or 4 lines. That is more than enough. Okay, that was about problem 2. Now for problem 3, it is a same function as in problem 2, but only difference is in the interval. Okay, so in problem 2, you will be finding the area in the interval 0 to pi by 2, whereas for problem 3, you will find area between 0 to pi. Got it? Now, in addition to that, they want something else. They want the error to be less than or equal to 0.01. Okay, they want the error to be less than or equal to 0.001. How can you do this? Okay, let me give you one hint, and if you know the answer, you can just drop it in the chat box. Okay, my question is, I want to reduce the error and it has to be less than or equal to 0.001. So what should I change to achieve this error? That's my question. So if you know the answer, please let me know. You can unmute or just drop it in the chat box. Okay, so I'll give you a hint here. Now we know that upper sum, for example, depends on delta x and f of x, right? Okay, now what does error depend on? Error depend on both upper sum, lower sum, right? This is the formula. So if I should change these two such that I have to get error as 0.001. Agree? Now, coming back to US here, upper sum and lower sum formula, I need to change delta x or f of xu to change the upper sum value, right? Now, can I change this f? I cannot change f because it is already given. Okay, can I change upper interval? I cannot change upper interval because this is already defined. They want us to find in this interval itself. So we cannot change the interval. We cannot change the given function. What can I change? I can change delta x. Okay, delta x is fine, right? I'm supposed to change only delta x. So to change this delta x, what should I change? So what is the formula here? B minus a divided by n. Okay, so this is the biggest hint. Now I am supposed to change delta x to get this error. Now what should I change in delta x so that I will get this error? That's my question. Okay, I will give you 2 minutes of time to answer. You can just type it in the chat box if you know the answer. Even the answer is wrong, it's fine. Okay, you can just give me any answer you like. So to change the error, what should I change? I mean, what variable should I change so that I will get this error? Very good, Arthur. That's the right answer. Exactly. So you have to change the value of n. Okay. Why is that? Because delta x depends on b, a, and n. But I said that you should change only n. That's because b minus a is nothing but the interval, right? You cannot change the interval or the function. You can change only n. Okay. So that's the biggest hint here. This is your assignment problem. I can give you only hint. I cannot completely tell you how to do that. Okay. Only hint is you are supposed to change the n value until you get this or until you meet this condition. Got it? That's your problem 3. Now, problem 4, you have a definite integral given. You have n given and I guess even the interval. Okay. So the interval is from 0 to pi. Fine. Now they want you to find the Riemann sum at the middle point. That means you're supposed to use the mid interval. That's the only difference. So this is the easiest problem among all. Okay, fine. We can do this as well. Now you have one theory question here. You're supposed to say how close is your MATLAB answer to the definite integral. That means you're supposed to evaluate this using MATLAB and also do by hand. Okay, solve this integral using hand and then compare your hand solution with the MATLAB solution, and you have to let us know how close is your answer. Okay, that's the question. Fine. So that will complete your LAB1 assignments. And you also have few additional questions, including the above one. These are quite easy. You can do that. Okay. Now I will show you how to do this using MATLAB software. So please open MATLAB software and we will get started. Okay. Okay. So once you open your MATLAB software, I want you all to click on open or click on new and then click on live script. I hope you all know this because you have completed your calculus 1, right? So open the live script and then just save the folder or the file in the name of LAB1 and save it wherever you want. Okay. Fine. Let's get started with this. So I will go with problem 1. You can type along with me. Okay. Now, first is you need to enter what function it is. So you are supposed to use inline command as I said you. Now it is with dot operation, right? 1 divided by x square. Okay. And then you need to find what is delta x. Now, you can include these lines if you want. This is not there in your lab manual, but this will really help you. Okay. Now let us see what is the interval. The interval is between 1 and 2. So A is 1, B is 2, and what is number of divisions? N equal to 100, right? So N equal to 100. Fine. Now what is delta x formula? Delta x is B minus A divided by N. Okay. Now I'm going to use semicolon in each and every lines here because I do not want this to be displayed on the output screen. Okay, delta x is fine. Now we are going to define the upper limit using linspace. Linspace, using the formula given here, xu linspace of 1 comma 2 minus delta x. One is a, b minus delta x comma n. That is going to be your upper interval. Now lower interval, same thing, but you're going to add delta x in the starting point. Delta x, b, comma n. Okay, and then we need to find the upper Riemann sum. The formula is delta x into summation. We for summation symbol we use sum in the MATLAB. Okay, now this is going to be xu because upper sum. So we are supposed to use only upper interval. I'm going to use semicolon here again. Okay, and then lower sum. Delta x into sum of f xl. Okay, great. Now we are going to find the estimate, or we are going to find the area. So I'll just name it as area here. Area will be equal to US plus LS. Keep this in the bracket, divided by 2. Okay, and error will be US minus LS divided by 2. Okay, that's your problem one. Now, if you want to add something, or if you want to answer the theory question related to problem one, and you don't like to just write it in the other paper and merge this PDF, if you don't like all those unnecessary things, you can always shift to text mode and then write whatever you want. So remember, for problem one, you are supposed to find the, or you're supposed to find the value of n such that the error is less than or equal to 0.001. Okay, you're supposed to do this for problem one as well. Along with problem three, you have to do this for problem one. Okay, fine. Now, you can also use section break if you want to. And I'm going to shift to code mode. Now, I'm going to write problem two. If you want me to slow down or stop in problem one, or if you want me to repeat, please let me know. I can do that. Okay. Now for problem two, they want us to find the same thing like we did for problem one, right? So I'm going to output to the right is fine. Okay. So for problem two, I'm just going to copy the same thing here, and I will tell you why I used ABN in the first line. Okay. Now remember, here you do not have to change in any of the lines. You just have to change A, B, N here for all the problems, right? You don't have to change anywhere in the formula. And that's the reason I used A, B, N in the first line, okay? Fine. Now here for problem two, we are supposed to change the interval 0 to pi by 2, and N you have to do, okay? I'm just going to give you the hint. Change the value of n. I'll not let you, I cannot tell you the value of n. You have to tell me what is the value of n so that I get my error to be less than or equal to 0.001. Okay. Now, along with the interval, we are supposed to change the function as well, right? Because this is for y equal to sine of x. Okay. So I'll come here and just type it as sine of x. Okay, and that's it. You don't have to change anything other than this. Now, I will show you some command here because let me shift to text mode. For problem two, please make a table which includes the value of n, delta x, error, estimate cost, area, error. Okay, I want these details to be in the table. Fine. Now again, as I told you, if you do not like to write it in a separate sheet of paper, you can create table in the MATLAB itself. Okay, I will show you an example here, just a random example. Now you know that your n values are this, right, given in the problem. Now let's say that these are just random values. You need to enter your values manually in the MATLAB. Okay. Now delta x, let's say I get 1, 2, 3, 4. Just a random value, and area to be 0.1, 3, 4, and let's say error to 0.1, 0.001. Okay. Now I want this to be in the form of table. So what do? Just give some variable there, and then you are supposed to use a table command. Now, if you want n to be appearing first, you can just say n delta x area error. Okay, very simple. Let me comment this. I don't want this to be executed. So one more cool command is if you want to comment multiple lines at once, you can just select all the lines and click on Control R. Okay, Control R. I'm not sure what the command is in the MacBook, but I guess it is going to be the Windows command with R, I guess so. But in other laptops, apart from Mac or Apple, so you are going to select all the multiple lines and then just click on Control R. Okay, that is going to select or make all the multiple lines to be a comment. That's one cool command you have. Okay, let me run this and I will show you how the table will be created. Okay, so you can see that you have a table here, right? But only one problem is this is arranged in horizontal way. I mean, I'm fine with n delta area and heading is fine, but I want the values to be one after another, arranged in a vertical position, right? So for that, you can just use a transpose. Transpose and transpose here. You can do that, or else you can use a semicolon instead of a comma. You can do either way. Now let me run this and there you go. You have your table. Okay, for different values of n, delta x, area, error. So you do not have to do this in a separate sheet of paper, right? Okay, so that was about problem 2. Remember, for problem 2, you're supposed to do this. You're supposed to do this for different values of n. Remember that, okay? For n equal to 10, for n equal to 100, 1000, 10,000, I guess that's it, okay? For these 4 values of n, you're supposed to find area. So problem 2 is going to be a quite lengthy code, right? Okay. Now let us shift to introduce a section break here because I'm going for problem 3. Okay. Now I'm going to use the same line of code. I guess the function is going to be sine of x, right? Now a comma b is 0 to pi. You can just take a look at the question here, question there. Now n value is not given. I'll just comment this. N value is not given in the problem. So you are supposed to change the value of n such that error is less than or equal to 0.001. Okay, here you have to change the value of n for the given values in the problem 2. Okay. Now everything is going to be same, but I just want you to change the value of n, and I want this value to be less than or equal to 0.001. Okay, that's the goal here. That's your problem 3. You do not have to change any formulas or introduce any new line of code. You just have to change the interval function and play with the value of n. Okay, great. Okay, that is going to be problem 3. Now let us go to problem 4. Problem 4 is to find a definite integral, and we are supposed to find only at the midpoint, right? Mid interval. So I don't need this upper interval or lower interval, nor the lower or upper Riemann sum, area and error. I do not need this. I just want the mid area, or I can just say it as estimated area, right? Estimated area. And this is at midpoint. In space A plus, okay, let's see the formula given here. Problem 4. This is the formula for mid interval. Delta x by 2. Okay, delta x by 2. Pi minus delta x, it's already written. That is divided by 2. Pi minus delta x divided by 2, comma n. Okay. And then you're supposed to change the function here. That is going to be x squared plus sine of x. Okay, x square. Remember, you have to introduce the dot operation plus sine of x. So you have to use the dot operation only if you have a product, not for addition. Do not use dot operation for to replace addition. Okay, do not make that mistake. I do not need the parenthesis here. Great, that's it. So this is going to be 1000, and this is from 0 to pi. Okay, looks good. And that's it. Okay, so this is what you are going to do for problem 4. Okay, now if you want to answer any theory questions, if it is given in your LAB1 manual, you can always go to text mode here. Remember, before answering any problem, you have to mention the question number first. So if you're doing problem 1, mention it as problem 1, type your question, answer, type your solution, and then shift to problem 2. Okay. If you want, you can also use section break as well in the text mode, right? Okay, so if you want your assignment to look good. So this is all about your LAB1 manual. So here also, before you start your line of code, shift back to text mode, write your name and date, and from which section you are. I mean the lab section, whether it is, I guess in your case, it will be 203. Okay, so this is more than enough. Or if you want to, you can just name LAB1 and just say it is Riemann Sum. Okay, you can do this. I mean, your assignment looks good if you do this, right? Okay. So this is going to be your LAB1. Very short, and probably you can complete this in 1 hour. So I would recommend you all to do it right now, and you can submit it because assignment link is already open. So you can submit it right away if you have completed. But if you want to take some time to answer the theory questions, you have 1 week. So make sure you submit your assignment before the due date. Okay. I'm not going to accept any late assignment unless your lecture professor allows me to do that. Yes. LAB1 is due on February 3rd. 1 week starting from today. Do you have any other questions related to LAB1 or Blackboard? And yeah, one more announcement. Yes, labs are recorded and I will be posting it in the Blackboard. One more announcement is that MATLAB license is going to be expired in 3 days. So if you are using MATLAB installed for your Calculus 1, you might have to contact IT desk to renew your license. Okay, make sure to do this because I don't want you to lose all your files. Okay. Okay. Any other questions apart from this? You can use the table command here. I mean, the video is recorded, so you can go back and play the video later on. Okay. Use this table command. It is going to be very easy. Now, to upload, as I said earlier, attendance is not taken. Maybe in person or Zoom. For this lab, there is no attendance. Okay, so even though you miss a lab, it is not going to affect your grade. Yes, if you have a MATLAB installed and it belongs to 2021, the license is going to be expired in 3 days. But if you have 2022 MATLAB, then I guess you're good. So if you want me to repeat any concept or the problem, if you have not understood, please let me know. I can do that. Or if you like to have a one-on-one meeting with me, that is also possible. Just email me your schedule and I'll just compare with my schedule. And if I'm free at the time, I can have a Zoom meeting. Okay. Okay. So handwork that is needed for problem 4, right? So you have to just scan that handbook and you can merge with your MATLAB PDF and then you can upload it in the Blackboard. Okay. I don't want the MATLAB file to be uploaded in the Blackboard. You can always export it to PDF, right? So before exporting, you have to run the file. Like once you see your output on the other screen, you can go here or here, export, click on export to PDF. It gets exported, right? And then you're good. If you want, I have already did this, so I can show you. Right? So if you export it to PDF, this is how it looks. You will have your line, I mean, your code, your output, everything. Even if you have written something in the text mode, that will also be visible, right? Okay. So Yeah, for problem 4, you have to do the AND work, and you need to show me the comparison, right? So, and that's the reason you have to scan it as a different file and merge the PDF. Okay. But if you think that you are not able to merge, you have some issues, you can just upload it as a second attempt. But make sure to notify me when you do that. Okay. I guess that will be the end of lab 1. So I will see you next week, maybe in person. I will be definitely in the class next week. So if you like to attend in person, you're most welcome. And one more announcement is that let's say that you are not free at the schedule, at this lab schedule, and but you like to have a live Zoom teaching or in person, then you can. I'm teaching other two sections of calculus too. That is on Wednesday from 1 to 3 p.m. and again from 3:30 to 5:20 p.m. So if you are interested, please let me know. I can send you the class schedule, location, everything, and you can stop by even if you have questions or anything. Okay. Yes, I will be uploading the recording today. As soon as I end the meeting, you can just log into your Blackboard, maybe after 10 minutes, and you will be able to see the video. Okay? Okay. It was really good meeting you all today. So if you do not have any questions, you are good to leave.